The function y equals log base b of x is the parent for a function family. You can graph y equals log base b of the difference x minus h plus k by translating the graph of the parent function y equals log base b of x horizontally by h units and vertically by k units. The a in y equals a times log base b of x indicates a stretch or compression vertically and possibly a reflection. Take note, concept summary. Families of logarithmic functions. The parent functions, y equals log base b of x, where b is greater than 0 and b does not equal 1. If given y equals a times log base b of x, we get a vertical stretch if the absolute value of a is greater than 1, a vertical compression, or shrink, if 0 is less than the absolute value of a, which is less than 1, and we get a reflection in the x-axis if a is less than 0. In the equation y equals log base b of the difference x minus h plus k, we get a translation horizontally by h and vertically by k. When we put all these transformations together, we see an equation of the form y equals a times log base b of the difference x minus h plus k. Problem 5. Translating y equals log base b of x. How does the graph of y equals log base 4 of the difference x minus 3 plus 4 compare to the graph of the parent function? Step 1. Make a table of values for the parent function and use the definition of logarithm. Well, for x values chosen on the left, 1/16, 1/4, 1, 4, and 16, log base 4 of x equals y, and 4 to the y power equals x. So 4 to the negative 2 power equals 1/16, indicating that y equals negative 2. 4 to the negative 1 power is 1 over 4, indicating that y equals negative 1. 4 to the 0 power is 1, so y equals 0. 4 to the first power is 4, so y equals 1. And 4 squared is 16, so y equals 2. Step 2. Graph the parent function. Shift the graph to the right 3 units to account for the x minus 3 in parentheses, and up 4 units to account for the plus 4 outside parentheses, to graph the equation y equals log base 4 of x minus 3 plus 4. We can see the graph here. The original parent function, y equals log base 4 of x, in orange, and its translated version, right 3 units and up 4 units, graphed in blue. Because y equals log base 4 of x minus 3 plus 4 translates the graph of the parent function 3 units to the right, the asymptote changes from x equals 0 to x equals 3. The domain changes from x is greater than 0 to x is greater than 3. The range remains all real numbers. Your turn. How does the graph of each function compare to the graph of the parent function? Part A. Y equals log base 2 of x minus 3 plus 4. And part B. Y equals 5 log base 2 of x.